We've got to do two things. Molarity, and the brackets here mean the molar concentration of what's inside of it. Molarity is moles of solute over liters of solution. Okay? And so we've got to do two kinds of conversions. We've got to convert the mass into moles, and we've got to convert the milliliters into liters. Now I can do that as a 3-step problem, or I can do it as a 1-step problem. Okay? I like to do it as a 1-step problem, and I think in an honors class there's no reason why you shouldn't. Okay? In fact, I've taught you one way to do it. I'm going to do it a slightly different way this time. I'm going to go ahead and put, since I know my solute is iron, I want to put it over on the top first. I'm going to put the given amount, 5.23 grams of iron nitrate on the top. And since I know I need my solution on the bottom, I'm going to go ahead and put it down there. Even though I don't have the right units yet, I'm going to convert it after I put it down there. So I want to have 100 milliliters of solution. All right?
Is it okay to do it like that every time?
If you're for this kind of thing, it is, yeah. All right. So this is kind of a shorthand way, a little bit shorter way of doing it. It takes out one step in our stoichiometry. It's not really stoichiometry, in our dimensional analysis. Okay. All right. So let's first of all we need to find our molar mass for iron nitrate. I'm going to do that right down here. I have iron and I have nitrogen and oxygen. And we get out the periodic table here and see that the mass of iron, the atomic mass of iron is 55.845, and the atomic mass of nitrogen is 14.0067. The mass of oxygen is 15.9994. Yeah, that's really kind of getting to be irritating, guys. Can y'all stop, please?
It's just one guy.
Just one guy?
Yeah.
Was that Hudson, or who was that? All right. We only have one iron, so I'm going to multiply this times 1. We have 2 nitrogens in the formula. This 2 outside the parentheses multiplies everything inside, times 2. And then we have 2 times 3, or 6 oxygens here. Okay? And so we're ready to do the math to find what numbers go in those slots.
All right. Can't wait.
So let's see, 14.0067.
Hey, there it is. Woo!
That's enough. Please. All right, if you're listening to this video, we're right at the end of the semester, and everybody's just kind of, you know. I'm sorry, Misha's not, but everybody else.
Gingers do have souls. That video has nothing on this video.
Let's just be.
What's up? Make that YouTube one. Gingers do have souls. I'm a Christian. I go to church.
All right, and we're going to multiply this times 6. You know, there's some person out there that might be listening to this who's saying, Mr. Tedder cannot control his classroom. They're going to think I'm a lousy teacher.
You're not a lousy
teacher. No. They just know we have fun in here. They just know we're retarded.
That'd be good. Are you putting this one on YouTube?
Probably.
Alright.
Alright, so there's the answer we get. And we have one empty slot here. So that means we need to round off this one digit at the end. We've got to round this number off, and we use an arrow to show we're rounding off. 179.855. That 8 rounds that 4 up to a 5. And that's grams of iron nitrate equals 1 mole of iron nitrate. And this is what I require in my class. When you finish, you've got to tell me units and species that apply to the number, And for calculating molar mass, you're always going to write an equality statement and say that this number equals a mole of whatever that is. So from that, then we can build a conversion unit. We need an equality statement for a conversion unit in this class because a conversion unit equals 1, and this is how we know it equals 1 because those two things are equal. So we're going to put our grams on the bottom so we can cancel grams in the species. So 179.855 grams of FeNO3 goes on the bottom. 1 mole of FeNO3 goes on the top. And we can cancel as we go. And if you hear people whistling, it's because I've taught them a little song. The whistle as you go, whistle as you work is the same tune we use for cancel as you go. All right, now we need one more conversion because we've got our starting amount into moles up on the top anyway. We've got to get this part of it down here into milliliters, and we need to convert. We need an equality statement for that to build a conversion unit. And the equality statement for this one is very simple: 1,000 milliliters equals 1 liter, and that's a definition. So neither of these numbers are going to be figured into our significant digits. So the milliliters are going to go on the top this time. I want to cancel milliliters. 1,000 milliliters go on the top, 1 liter on the bottom. That allows me to cancel just the milliliters. And as a result, then we've got moles of FeNO3, which is our solute, over liters of the solution. And all we have to do is plug in and do the math.
Let's go. Let's do it.
Okay? Misha, did you have a question about this process?
Yes, sir. Is it possible that we can just put 5.23 grams of iron over 1 and then separately do like 1 over 1?
Yes, that's the way I've taught it before. So what the question was, can I do, instead of putting this on the bottom here, can I put 1 over this number over here as a separate step? Yes. I was just condensing the steps. I said in the beginning I was going to condense the steps by 1 step here. Okay? Or I said I was going to condense it. I didn't say if it was 1 step. I don't remember if I did, but I might have. Okay, anyway. So everybody has a calculator out?
It's about to be.
Well, we're practicing for the final exam. You should have paper, pencil, calculator. Yes, if you have to.
2.5. I mean 1.5.
Why should I do all the math for you?
Because your calculator's famous on YouTube.
You know, this is a really old-style calculator.
No, it's not. It's 1982. Unitrate? Just kidding.
I've had this calculator for like 15 years. No.
That's experience. It's on that. This was about 3 months after the SAT.
All right, so the way I've taught students to do this is to take this number, multiply by that number, hit equals, then divide separately these things on the bottom. So divided by 100. Whoop, divide by 100 here. Let's do divided by 100. Whoop, got to put the answer in there. Should pop it up if I'd done it right. Would have popped it up there automatically. Divided by 100. And I hit enter, and I'm going to divide this as a separate number. Divided by 179.855. Just a fast way of putting it in the calculator. Do it that way. And so the answer we get then is 0.29078 Okay. Units of measurement that we have left are moles of iron nitrate. Divided by liters of iron nitrate solution. Okay, we want to round that off using the significant digits rules we've been taught in this class. We're going to look at the measured or calculated numbers, and only the measured or calculated numbers, to figure out the significant digits. This is measured, this is measured, this is calculated. These other numbers don't really matter in our determination of significant digits. And all of those numbers, this has the least digits, 3, so our final answer needs to be in 3. Leading zeros are not significant, so we start underlining from the 4th digit, from the first of the significant digits, counting to the right. And so now we want to round that off. Our final numeric answer is 0.291. And since moles of solute over liters of solution is molarity, or molar concentration, we can write the answer in this form. Molar, FeNO3 solution. And that would be the answer right there we're looking for. Notice I put a line under molar because it's easier to tell if it's a capital letter there. And that's important because we have another unit of concentration that has a small letter in it.